Okie doke. So we need to do some file I/O. In the next lab, the user creation script lab, you'll be reading a file of names and then doing stuff with each name depending on what the command line option is. And so this should set you up pretty well for that. For example, you can look at the user creation script instructions. So what I'm going to do is something similar using different commands and a different file, but a structure that you could borrow for that assignment. And I'll be using principles that we've discussed already, plus adding a few things. So first let's look at our data file. Cat is a concatenation command, and I can cat and then specify a file name. I have a captain's data file, captains.dat. So that's some notable captains and their ships in chronological order of the original timeline. And we'll be reading that file and then writing a program that looks at options on the command line. So I'll call the program liner.sh, liner.sh. And the first parameter will be the input file name, and so I'm going to type captains.dat on the command line when I call it. The second parameter will be what I want to use as an output file, so I can make up whatever I want. I think I'll call it captains2.dat when I run it. The third parameter is going to be what do I want it to do. I'll put a -L if I want the output to be last name first, and then I'll put an F if I want it to be first name first. And I'll put a -N if I want it to display a particular line number, and I'll do a -S if I want it to do a search for a pattern. All of these things might be useful in upcoming labs. Well, maybe not all of them, but there will be some very useful things. So here we go. So let's start g-editing this thing. Liner.sh with an ampersand. Boink. There we go. #bang/bin/bash. And let's start. So just super simple. Let's echo $1 is and $1. An echo $2 is and $2, just so you can see this first. So this is just a super being able to see how command line options work. So let me save that. And then over here, let me change mode, +X on liner.sh. Change mode, that looks good. So if I just run liner.sh, $1 is, so see how I have single quote? If I say single quote $1 space is, remember in bash, if you use single quotes, then it literally prints exactly those characters. It doesn't do a substitution of $1 for its content. If I don't use quotes, or if I use double quotes, then it'll take $1 and $2 and replace the contents of those variables with replace this position with the contents of those variables. It'll show me what's in those variables, $1 and $2. So $1 is /liner.sh. So if I say BANANAS, go bananas, press enter, then I get echo $1 is, and then the contents of $1 is the first thing on the line that I type. So this way, from inside the program, I can see what the user types when they type in a command. This is how operating systems work. This is how shell scripts work. and you can see inside, from inside the program, you can see what the user typed along with the command. Very useful, because most commands have lots of options, and this is how you can see those options and then behave differently depending on what the options are. So if I run it again, bananas and ice cream, then I see bananas is $1 and ice cream is $2. So it's positional. Whatever you type first is in $1. Whatever you type second goes in $2. And so we'll use that on the inside. Okay. So we want to read a file. So let's look at the simplest version of reading a file. I can say while read, and then I'll just read everything into a variable called line. And so it's a while loop. Do echo $line, done, and I need to tell it where to get the input from. So we'll do that. So this is input redirection. There is a video that is a nice description of input and output streams and piping and redirecting input and output to their non-default sources. And this is an example of that. So I didn't create a whole new video. It's about 20 minutes and it's very thorough and it's really nicely done. So I'll let you watch that on File.io. And this is an example of redirecting the input stream. Normally, standard input comes from the keyboard. And in this while loop, I can say I want the standard input to come from a data file. So I'm going to take my captains.dat file, and that's going to be my input file, like that. So what this little script says is read into line, the variable line, from the data file captains.dat. For each line I read, echo out that line to the command prompt. So I'll save it and I'll run it. Oops. Oh yeah, that did work. I hit the wrong key, but I had a key that worked. Let's clear the screen. I should just type liner.sh all by itself, and it runs, and it says, oh, because I didn't tell it where, /liner.sh, and it runs. And so what it does is it finds captains.dat, and then reads line by line into the variable $line, and for every line it reads, it echoes that line. Pretty simple. So this just shows that we can use a script to read a file. This is pretty much what the cat command does. If I type cat captains.dat, it goes out, finds captains.dat, and it, line by line, takes the contents of captains.dat and puts it out to the screen. So we pretty much just wrote code that duplicates the cat command in DOS. This is not DOS. This is bash. Okay, let's make it a little more clever. Let's say that $1 is the input file. And instead of reading from captains.dat, we'll read from $1. Now, I can say ./liner.sh captains.dat and press enter, and it reads captains.dat. If I want to say ./liner.sh and the file that I want to read is liner.sh, it'll output the contents of whatever file I pick. So now I've given the script more flexibility by using $1 to read the first thing that the user typed after they typed in the command. Inside the program, I've got a comment to remind me that $1 is going to be used for the input file. Okay? It's positional. So whatever you type after a command, the first thing is going to go into $1, the second thing is going to go into $2, the next thing is going to go into $3. That's the way Bash works, so you'll be using that. Okay, let's say let's do output. Let's say $2 is the output file. So I can echo the line, and instead of sending it to the standard output, I can use this double greater than sign. And if you watch the video about output redirection and input redirection, this symbol says redirect the standard output so it doesn't come to the screen, but it goes to a file. And the two greater than signs say to add to the file or append to the file. And so what we'll have, I'll just make a new file called, how about data out.dat. That sounds all official. Data out.dat. Does that look right? Yeah, I think that looks right. So first, I'll force it to go to just that one file, data out.dat. So I'll type in liner.sh, and I'll go back to, I'll start getting consistent. Captains.dat is going to be my input file, and the first time I run it, I won't put $2 because I'm just forcing it to go to the file called data out.dat. So when I run the program, I don't get any output to the screen anymore. But if I cat data out.dat, there's my output. So I'm going to remove data out.dat, and in here, instead of forcing a specific file name, I'll use $2, and now whatever I type, the second file name that I type after the command prompt, that's going to be the output file. So now, excuse me, now I can type liner.sh, and then my input file, captains.dat, and then my output file, I'll just say out.dat this time. That looks good. Press enter, and I don't see anything. So I'll cat out.dat, and no such file or directory. Well, that didn't work, did it? Read echo $line to $2 out.dat liner.sh captains.dat out.dat. But I don't have out.dat, even though I've got it in here. Did I save it? Let's save it and run it again. Liner.sh captains.dat, that's what I'm reading in. My output file is $2 out.dat. cat out dot dat. There it is. I must not have saved the file when I ran it the first time. Yay, good example of debugging. Okay. Okay, so that works. Phew. Let's add some options. So now let's make it do tricks. So $3 is the option. And I'm going to say -L prints last name first, -F first name first, and we'll just start with that. Save that. So if I want to separate last name and first name, here's my input file. The first field is going to be the first name. Oops, nope. James Kirk. Yeah, the first field is the first name. The second field is the last name. The third field is the ship. So instead of just saying while read line, in Bash, the default is to use the space as a separator. So I can refer to those individual fields. I can say while read F name space L name space ship. And now, when I echo, instead of echoing a line, I can echo $F name and $L name and $ship. So let's do that before we, and save it this time before I run it again. Clear the screen. Oh, I should get rid of out.dat also. rm out.dat. And run it again. Liner.sh, captains.dat, out.dat. Make sure that this syntax works okay. It runs. Now if I cat out.dat, yep, still working. Good. So see that I can specify F name, L name, and ship independently now. So in here, I could say if square bracket, if $3, or the third option is a -L, so equals quote -L quote square bracket semicolon, then I want to do I'm going to echo, but I'll take this echo line, Control C, and paste it up here, Control V, and I'm paying attention to my indentation very carefully so I don't drop any ifs or elifs or FIs. Ifs and elifs and FIs that mark the beginning and ending of conditional expressions, it's easy to get that messed up, so be careful with your indentation. Okay. So we'll do that comparison. If option 3 is a -L, print it that way. Elif, and I'll just copy this code, Control C, put here, Control V. So elif is a shorthand version for else if. So else if $3 is a -F, then I'll echo it this way. And then fi finishes the block. So if this comparison is true, I'm going to do first name, last name. Oops. Haha. Good catch. That's why I say things out loud. Even when I'm by myself and I'm programming, I'll say things out loud if I want to make sure I get it right. So if this condition is true, do last name, first name. Else, if this condition is true, do first name, last name. Now we got something going on, so I'll save that and run it. So I've got out.dat. So first I'll use the -L to make it go last name, first name, and press enter. And now I can cat out.dat and notice that whenever I echo to out.dat, I'm appending to it, I'm adding to it. And I didn't remove it the last time. So these first four are from the last time I ran it, which is kind of nice because the last time I ran it, it used the default of first name, last name. This time I ran it, I added a -L. So it processed the 4 lines and added to the output file. But now we can see that I've got it last name, first name. So it saw the -L, saw this comparison to be true, and so it built the new output with last name, first name. Excellent. Okay, let's do another trick. Actually, there's a counter trick. You can look that up in the code and implement it and try it out. It's a line counter thing. I don't want this to get too long, so I'm going to do something that might be more useful to you. A -S. So let's do a search, and I'll show you the syntax for a search. And I don't expect you to remember this stuff because you just look it up as you need it. Google stuff all the time. So if I do a search, then that means I want to say that $4 is going to be the search pattern. So if I have a $S, or if I have a -S as my option 3, that means I'm going to do a search. And the thing that's going to come with option 4 is going to be the search pattern. And so that can be kind of slick. So let's add another if for a search pattern. And that looks like elif, square bracket, square bracket. So if $3 equals a -S, then we're going to do something different. First, I need to do some kind of a pattern match. And in my if expression, I just want to take, right now I've got first name, last name, and ship all broken up, and I want to search for a pattern in there. So like if I'm searching for a name and I want to get that line and see if that line is the one that I want, then I want to take the first name and the last name in the ship and add them together as one big string. And so I'm gonna reconstruct the line by saying line equals $F name, $L name, $ship. So I'm saying that I'm creating a new variable called line, and it is going to consist of first name, last name, ship, which is a reconstruction of the original line. If I wanted to perfectly reconstruct the line, I would put it in quotes and I would separate with spaces. But I don't need to do that because I'm just going to do a pattern match to see if, like I want to type in NCC and get all of the starship captains. Or I want to type in, I can't remember Ben's last name, and I don't know if he goes by Ben or Benjamin, so I just want to be able to type in Ben and have it do a pattern match. That kind of thing. So first I'm going to reconstruct the line, and then I can do a nested if comparison. So I've got this is cool. We've got inside a while do done block a series of ifs. And if this is true, you do this. Else, if this is true, you do this. Else, if this is true, you do this. Fi ends this if block. So you get messed up if you don't track your indentation. Okay. So I got the line, and I'm going to do inside this elif fi block, I'm going to have another if statement. First I build my line, And then I've got another comparison. If $line is equal to, and I'll use a wildcard. So if you remember in IT 105, a lot of time the asterisk is used as a wildcard. So in this case, I could use this way of doing a comparison against strings. Star, and then whatever's in $4, and another star. So it can start with anything, and it can end with anything, but it needs that pattern somewhere in it. And then I'm going to compare the line to that. And if the line contains this pattern, then this statement, this comparison, will evaluate to true. So if that's true, then I will have found it, and then I can just echo to Control C, echo to the standard output. I don't want this to go to the file. If I'm doing a pattern match, I want to be able to see it on the screen. So here's why I pay close attention to my indentation. Now you've got ifs and elifs and more ifs and a couple of FIs. And so in order to get this all right, you gotta, the easiest way to do it, and the way professional programmers do it, is by watching your indentation, making sure that you line up the nesting levels of all of your if statements or all of your indented blocks. Anything you got, anytime you have a condition that has to be compared before you continue, anytime you've got some kind of a block of code, manage your indentation so that it's visibly very clear where one block starts and one block ends. So now I've got, I'm doing a lot of indentation. So I've got a while loop which executes every time I read a record from the file. And then inside that while loop I have an if-elif block which is checking for option 3, and it's changing its behavior based on if you want to do last name first name or first name last name with a file output, or if you just want to do a search of the file and then output to the standard output. So in order to have the right brackets, so I've got if, elif will close out this block, this elif closes out this block, then I've got a new if that's inside this elif, this fi closes out that if, and then when I get to the end I still need to close out this if block, so I need another fi that matches this one. So I think that looks like that should work. So I'm going to save that and I'm going to run it. So this time, so I've got the input file, output file, but this time I'm going to do a -s, and I'm going to search for a pattern. And $4 is going to be the fourth option on the line. And so let's say I'm going to search for, let's just say I'm searching for Ben like before. And so if I press enter, then I get, Benjamin Sisko DS9. So what happened is I said $3 was a -s at the line, and I gave it a search pattern of Ben. And so when the program started, it reads the first line, which has Kirk in it, and then goes through and it compares. Am I searching? No. Well, I'm searching. It's a -s. Is it a -l? Nope. Is it a -f? Nope. Is it a -s? Yes. So then I reconstruct the line, and then I compare. Does the line have the letters capital B-E-N in it? And if it does, then I echo first name, last name, and ship. So the first time through is Kirk, and so it's true that $3 equals a -s, but when I reconstruct the line and compare the Kirk line to see if it has Ben in it, this is false, so it doesn't echo anything. So it gets the next line. Reads first name, last name, ship, and now it's got Picard in it. It's not an L, it's not an F. $3 is a -s. It builds the line, it compares the Picard line to Ben, and this is false, so it doesn't echo anything. So it goes back up to the top. And now it reads the third line. So this one has Benjamin Sisko DS9 in it. And so the dash L is not true, the dash F is not true, the dash S is true. So it reconstructs the line with Benjamin Sisko DS9. And now $line does have the word Ben in it. And so this evaluates to true, and the echo F-name, L-name ship goes out to the screen, Benjamin Sisko DS9. Then it goes back up and checks the Janeway record, and with the dash S, does not match Ben, and so nothing comes out. So I just had one line that matched for Ben. Now, if I run it again, and this time instead of searching for Ben, I'm searching for NCC. I want to see all of the people that were captains of ships, not deep space stations. And so now I'm comparing against NCC, and so for 3 different records, this line comparison, this line comparison, $line equal $4 was true. So Kirk, Picard, and Janeway all captained NCC ships. All right, that's a little long, but now we've got a super useful script that reads files, writes files, and behaves differently depending on what you type at the command prompt. It knows how to look for a pattern in a file. It knows how to read individual fields within the file and resort those fields in the output. So that's going to be super helpful in the next couple of labs.